Alright, hey, it's Jeff here. Hey, I want to show you some more aircraft carnage. Evidently, y'all like that. I don't understand why. It's like going NASCAR just to watch the wrecks, but hey, whatever you want to see, I'll try to show it to you. What I want to show you today is what happens when you don't extend the flaps all the way on an aircraft that has spring-loaded flaps that are spring-loaded in the retract position. This aircraft actually has a placard inside that says extend flaps when parking. And nowhere in the POH on this airplane does it stated in the checklist. Um, so a lot of people wonder, why would you extend the flaps and hold spring tension on it? Well, the reason is if the flaps aren't extended all the way and they basically float, and what happens if you get a bad gust of wind from the backside of the airplane, either when it's parked, tied down, and got straight line winds with the front coming in, or say you're just pumping fuel, you don't have your flaps extended all the way, and someone comes up and say they're on the ramp taxiing around, they're not paying attention. You got a lot of those people out there, a lot of new pilots out there. Uh, Anyways, it is what it is. But a plane can whip around, the prop blast can hit the back of the flap and slam that flap down and actually go beyond what it's meant to travel. And it start tearing up metal when you do that. And let me show you what happened. Now, as far as the chain of events that caused this to happen, I'm not sure what caused it. The owner of the aircraft isn't quite sure either. He's not sure if it's his fault, he didn't extend the flaps, or what, but comes out one day, and actually I go out to the plane one day to do some other maintenance and I find the problem. Anyways, let me show you what we got here. I'm going to stop the video and reposition the camera. It's still one shot. It counts. I don't care what you say. Okay, here's the bottom of the right wing, and you can see where it's lipped over. Try to set this down. You see where the skin is lipped. It's actually bent right here. There's a crack right there, and here's a crack right here. So what I do is I pulled the flap off and I'm going to build a doubler right here. We got to transfer the strength that this once had into the new piece. I've already started drilling up some of my holes for it, but I figured in the middle of this, hey, might as well show you what's going on. Like you said, you've got a bunch of NASCAR fans. Why don't you just see the wreck? Here you go. Here's the wreck. All right. And here's that spring I was telling you about. That's what holds this flap in the retract position. Okay, let's show you the other side. All right, here we are. We're on the left flap now. See if I can get the camera angle in here. Taking the flap off is kind of hard to see, but you see this new shiny metal? That's actually a spar I had to build. You can't find parts for these airplanes anymore. So I had to actually build this part, and it did quite a big extensive damage. In fact, this plane was not flyable. The flap was hanging down about 20 degrees when everything was retracted because of this. Was totally broke off. Alright, here's that spar I was just showing you that was on the left flap. You can see the damage this piece took. It totally ripped that out. There's part of it. This part sat in there like that. That was like that. And this was a bracket that was actually on the back side of the rib. That attached to the back side of that. It just pulled the rivets out right here and just destroyed these pieces. Now luckily the main bracket survived. It's made out of steel, but these other parts are aluminum, and that's what gave. Alright, here's what I want to show you what I'm talking about with winds hitting from the backside of the airplane causing a lot of damage. You know, you park with the plane with the flaps up, front comes in, or an airplane, and slips, turns around, or a helicopter flies in the air, and you get the wind from it. It hits this flap. You can actually hit it hard enough to jam it, and there's no stop on it. I mean, the stop is the end of the travel. Well, it can go beyond it, and that's when metal starts bending. That's when you've got the damage in the spar. You get damage right here, and you get damage up underneath here. Okay, here's the new piece I'm building up. It's just rough cut right now, the shape I need. I'll trim the edges once I get all the holes drilled up and put it in place. I've got a lot of my pilot holes already. I'm keep picking up the rest of these holes. Once that's done, I'll sand this lightly with a piece of Scotch-Brite. Get the surface something for the iodine to stick to. The customer's going to paint it later, but for right now it's going to be bare aluminum, so you got to protect it when everything is drilled up and installed. So I'll drill a couple holes, stop the camera, I'll get my work done, and I'll turn the camera back on when I get ready to start riveting. Alright, sorry about that. Stop the camera real quick. Compressor kicked on. So, anyways, I'm going to pick up a couple of these holes. Show you how I'm doing that. Basically, I've already located my holes, measured out what I want my spacing to be. Took my center punch, hit my mark, so now my bit doesn't wobble all around. Alright. And I'm picking up each hole, and I'm using this piece of wood as something to give me something to back up against. And before any yahoo out there says, well, how are you going to drill a straight line without using a drill guide? Well, I got one. If you need one of these, okay, go ahead. Use one of these, rookie. But if you're rookie, can't drill a straight line to save your life, or you like to drink beer all day and then drill your holes, I suggest using that. Let me show you how you use this. Basically, this is just a bushing that keeps your bit straight. Okay. Hold everything tight. It's just that easy. This ain't my first rodeo. I can drill a pretty straight line. I only use this if I'm in a really tight area where I can't get straight on the part. But other than that, I just do it by hand. Easy as that. Okay, got my part cleat-coated in place now, and I'm going to start picking up all these holes that I measured out and drilled out on the toolbox. In case you're wondering why I made the beer comment about some of you mechanics out there, I know some of you got to be just getting hammered and work on these airplanes, because if you're watching my video that posted about that annual that needed that pre-buy, there's no other excuse for the plane to be in that condition, and that mechanic had been just getting hammered. And for that matter, the guy that bought that airplane and was pre-flying that thing daily and flying it and hacking up the instrument panel. One excuse, you gotta have some alcohol involved on that one. But if that offended you, sorry. Okay, I drilled up all my holes. Now I'm taking the part back off, and I'm using this tool right here. In case you're wondering what that is, this is so I can deburr the holes. One of the byproducts of drilling into metal, you get all these almost like splinters in the metal in the hole, and you need the hole as clean as could be when you put the rivet in. That way, it makes a stronger bond, and also it's less prone to start cracking around the rivet head. So anyways, this will clean up all the holes. And now we're trying to cut the metal, you're just trying to clean the hole out. I've already done the part. I'll do the outside skin here, then I'll get inside the wing and do the inside. And I figure I'll do another full body shot with the camera. This is for you ladies. Okay everybody, here's the finished repair. It's all iodine, riveted up. And there is no SRM or service repair manual on this airplane. So you had to go by AAC 4313 for rivet size and spacing, and everything is done in accordance with AC 4313. Anyways, that's it. Thanks for watching everybody.